In this chapter, we'll look at primitive data types and their application. Java is a statically typed or strongly typed language. What this means is the variable to be used must be declared of some type before it is used. There are two types of data that are supported in Java. One is primitive data types, example int, and second is non-primitive data type, example would be string class. Let's take a look at what primitive data types are. So primitive data types are predefined by Java. They're available off the shelf. So there are totally 8 primitive data types that are available as part of Java. The below table describes the different data types. Let's take a deep look at each of the data types. Byte data type is of size 1 byte. Typically, it would be used to store a stream of data or a serialized object. Short, int, and long. Their size is 2 bytes, 4 bytes, 8 bytes respectively. All three of them stored signed numeric values. You can see that the default values is 0 for them. Float and double allow you to store decimal values. Float data type is a single precision 32-bit floating point, whereas double data type is a double precision 64-bit floating point. Both float and double data types were designed especially for scientific calculation, where approximation errors are acceptable. If a higher accuracy is required, then it is recommended to use big decimal class. Char data types takes 2 bytes for storage. It allows you to store Unicode value. The value itself is stored as a numeric value. Boolean represents only one bit of information, either true or false. Hence the valid values would be true or false. The storage size for Boolean is 1 byte. So JVM is free to implement it as 1 bit. Let's take a look at a demo example for primitive data types. Here we have defined a class primitive data type demo. Within that class, we have declared or defined one function, check primitive data types. So it's a public static void function, and we'll be calling this function from the main method. So in here, the value for bool value variable, we are assigning it to true. You can try to see that if we assign some other value, it is showing compilation error that we cannot assign an integer to a bool value. Let's take a look at the character values. So we have defined two variables, character value and character value 2. To character value, we are assigning a character A, and to character value 2, we are assigning an integer. So as we mentioned, uh, internally character is still stored as an integer or a numeric value. Hence, what is going to happen is when we print this, it will be actually printing the ASCII equivalent of integer 67, so which is going to be C. Next, we are having a variable byte value of type byte, so we are assigning an integer to it. Next, we have short value, int value, long value, to which we are assigning integer values. Next, we have defined float value variable of type float, and we are assigning some decimal value to it. So we have to specify a prefix of f to indicate that it is a float value. Similarly, we have a variable double value of type double, and in order to indicate it's double, we have to suffix it with d. And the successive statements, all we are trying to do is we are trying to print the values of those variables. And if you run this program, you'll see that it is printing these values. So if bool value is true, that's what we had assigned here. Char value is A, that's what we had assigned here. Char value 2 is C, we are assigned an integer which is basically the ASCII equivalent for 67 is C, so it's printing C. These are all numeric values. You can see that it is printing exactly the values that are assigned. Similarly for the float and double, it is printing the values that are shown here. In the table, note that each numeric data type has minimum and max limit. The question to you is, what will happen when a variable is storing a max value and one tries to increment it? Let's try this with a demo example. Let's create a class increment max. And we're going to add the main static void. We'll define a byte value and we'll assign byte.max. We'll do a system out to print this value. Then we'll try to increment the value, and again try to print it. We'll call this function. So let's see what is going to be the result of this function. So let's see what is going to be the result of this program. Now you can see that we are assigning max value to a variable of type byte. So the max value is 127, so it's printing that. Now we are trying to increment this. So this is plus plus in an increment operator. We'll be learning about operators in the upcoming sections. But all it's trying to do is it's trying to take this 127 and add 1 to it, right? But since byte has a limitation in terms of the max value it can store, so that is 127. So all the numeric values are stored as 2's complement. So incrementing the value which has got a max value will change it into a negative value, and that negative value will be the minimum value that can be stored in that particular data type. So in this case, it is going to be minus 128. So similar behavior will be exhibited when we try to do the increment operator on max value of int. So it will get converted into minimum of int. Same thing with short and long values as well. There might be situations where the invoke method is a returning value of certain data type, but because of certain limitations, we want to store it in different data types. Let's see this in more detail. So when the conversion happens from lower to higher data type, it is allowed and it is implicit. A quick example here. So we have a short value s variable where we have assigned it value 10. Now we are trying to use an integer value to store the short value. So here the short value is implicitly getting converted into int value, and this is all okay. In the second case, we are trying to store a higher value into a lower data type, and this is not allowed. Let's take a look at the example. So in here we have int I equals to 10, and we are trying to store it in a short data type s equal to I. So this will not be allowed by the compiler, and it is going to throw an error. So in this situation, casting is required. In cases where the value cannot be stored in the destination data type, it will result in truncation. So we have to be very careful in doing casting. So here is an example. So again, we have int I equals to 10, and we want to store this in a variable s, which is of type short. So we are doing short s equals to casting it to short I. In this case, there's no error, but as a word of caution, make sure the values that you're trying to store is not. Let's take a look at a real example here. So we have created a class primitive type conversion. We're going to introduce a function which is going to compute the number of seconds in year. Now we'll try to consume this function or call this function from the main method. So in first case, let's try to store this as a long. So the function itself returns a long, and we are trying to store this in a long. So as you would expect, this should run fine and there should not be an issue. So we are seeing that it is printing the results accurately. Now we'll try to do is we'll try to store this as int. Naturally, since the value itself is coming as long without the cast, it is going to give us error, right? So hence, we need this cast. So if you try to run this program, so again, it is able to cast it to int, and the value is retained. The value is retained correctly. There's no truncation happening because it is not going beyond the max of int, right? So let's try another case where we are trying to store this in a short type. Basically, the value assigned to this particular variable, we're trying to use this value and store it in a short. Naturally, a typecast is required, so we are casting it to short, and we are trying to print the value. Let's try to see what the result is. So here you can see that the value being printed is different. So why is this happening is because this value is too large to be fit into short, hence this results in truncation. So we have to be very, very careful when we are doing casting. Generally, we should try to avoid casting. Let's take a look at what are literals. So literal is a constant value that is assigned to a variable. So very simple. So here are some examples of the literal. So for a char data type in single quote Z, this will become a literal for character data type. So we are doing char C is equal to in single quotes Z. Another example, int, the literal value is like 10. So it can be done in different ways. So for example, if my variable type is int, let's say it is sum. So we want to assign 10 to sum. So we'll say int sum equals to 10. Another way to assign the same value is we prefix it with 0x, so which tells me that the values after that is a hexadecimal. So 0x 0a. So the resultant value will be same. So it will be 10. 0a in hex is 10 in decimal. So if you want to assign this using a binary literal, you'll have to prefix it with 0b. So 1010 is the binary equivalent for 10. Now you can see one peculiar thing here. So what we're trying to do is we are using 0b, then 10 underscore 10. So this underscore is just for readability. So actually it is assigning 1010 as a binary value to the integer variable sum. So just to improve the readability when the numbers being used are large, In that case, we can use underscore to separate out the digits. The last example, we have Boolean. The literal here is like true. So an example of this is Boolean today's a working day equals to true. So let's recap what we learned in primitive data types. So Java is a strongly typed language. There are 8 primitive data types: Boolean, char, byte, short, int, long, float, double. Implicit casting happens when assigning from lower to higher data types. Explicit casting is necessary when assigning from higher to lower data types, but be wary of truncation issues. Default value for numeric is 0. It's a bad programming practice to not initialize a variable. Literals are constant values assigned to a variable beyond the max limit of the destination data type.